Hi class, this is your first video that belongs to you, summer of 2012. I promised you that I would give you like 10 or 15 minutes of some thoughts I have or things that I think are important. And today in my office I felt like I learned a few interesting things from working with students, and I thought I'd share them with you. Just a few ideas that we were kind of like throwing around about how to solve these problems in different ways. So I put this nomenclature problem up on the board, and I apologize to the people who are in my office today because it's kind of similar to what we were doing. But I just thought some of the things that came out were kind of interesting. So this would be like kind of a pretty tough nomenclature problem. It's a little tougher than what you might do on this test in terms of the number of asymmetric carbons, but it should be doable regardless. So let's name this compound. So let's once again go through the rules for naming. The first thing is you have to pick the parent chain, and it's important to realize that the parent chain has nothing to do with numbering, and unfortunately I think people leap over into numbering when they should be focusing on the parent chain. And the parent chain, there's four things you do when you pick out the parent chain. The first thing is you look for the greatest number of substituents corresponding to the highest priority groups. Okay, now in this molecule, the highest priority group would be the alcohol. Okay, so you'd want to get the longest chain from end to end that would include that alcohol. Okay, so this alcohol has to be in the chain. So obviously it would either be this chain, right, or it would be this chain. And I hope I'm not making an error there, but it could not be this chain because this chain does not have the alcohol in it. So then at the second level of consideration, what you're looking for is getting the greatest number of double bonds into the chain. That's your second level of consideration. So, and it's not the chain length yet. It's just the number of double bonds. So when I go this way, and believe it or not, this chain starts here, okay? All right, now notice we can't incorporate these double bonds into the chain, okay? We can't incorporate them because they're part of this ring, and you have no way of doing that. So the chain would really go from here. So I could pick this chain, which has one double bond, or I could pick this chain, which has one double bond. So they both have one double bond. So they kind of tie at that level. So then you go to the third criterion, which is the length of the chain. So that being the case, because we've done a lot of stuff with substituents, but I want to talk about the length of the chain. All right, this chain is shorter than this chain. So this chain has both an alcohol and a double bond in it, and it's longer. Okay, the next level would be substituents, and I know you did a number of problems where there are a lot of ties, but I just want to show you what happens when you actually go to the length of the chain. So in this case, it would be this chain. Now then the second thing you do is you talk about numbering. And this is why I referred you to that Loudon appendix. And again, there is nothing wrong with reading Loudon. Loudon is fantastic. And by the way, we're in chapter 6 right now in Loudon. But his list, his criteria are really good, and they're really sharp, and they really help you. Now for numbering, what we want to do first is get the alcohol in the lowest position, and you're going from end to end. Now remember, it's only in a ring where you make the alcohol number 1, and it's only in a ring where the alcohol numbering might be redundant. Okay? So in this case, I would number so that the alcohol would get the lowest number. If I had two alcohols, like if I had another alcohol down here, I would pick the direction that gave the double bond the lower position. So it's highest level substituent. Next thing is double and triple bond numbering. Next thing is substituent numbering, and lastly it's alphabetizing. That's kind of the way it works. So in this case, I would start numbering here. I'd go 1, 2, 3, 4, 5, 6, 7, 8, 9, okay, because it's a longer chain and it has a double bond and an alcohol, so it meets all the criteria. So what would this compound be called? This would be called a known ene all. And a lot of people were asking me about spelling. If the suffix has a vowel beginning, you drop the E off the known ene. If it has a consonant beginning to the suffix, you would leave the E in. It's very much like spelling. Like if I were putting an ED ending on like a word that ended in a vowel, I would drop the E. Remember, drop the E when the suffix begins with a vowel. And this includes Y, okay? Y is considered to be a vowel in this context. Okay, so it's a nonenal. The alcohol is in the number 2 position. There's a mistake people commonly make where they call this number 1. So this is a nonene 2 all, okay? And the double bond is in the 1, 2, 3, 4, 5, 6, 7, 8 position. So it's an 8 nonene 2 all. Okay, what are these side chains called? I wanted to talk a little bit about this kind of side chain. This is a cyclopenta. I just wanted to show you something that had 2 double bonds in it. Dienyl side chain. And you have to number where those double bonds are. So the double bonds are in the 1 and the 3 position. So this is a 1,3 cyclopentadienyl side chain. Okay? This obviously is just a bromo. Okay? So that's not so exciting or complicated. So that's a bromo. And then this, right, this whole thing has to be named. That's not the easiest thing in the world to name. So what is that called? The main chain goes out this way. I would go out this way toward the double bond. So it's 3, 4. So this is a 2-butenyl chain, okay, but it has a side chain coming off it, and it actually has a branch off the branch. So if this were just a CH3 group, it would be a methyl, but this is really a chloromethyl group. And I wanted to bring this up because on your quiz answer keys, I talked a little bit about redundancy. This is another situation where you'd have redundancy. If you have a substituent on a methyl group, you don't need numbering. You don't need numbers on it. So this side chain would be a 2, I think I'll put it in parentheses though. It's a 2 bromomethyl in parentheses, okay, 2-butenyl group, and then the whole thing, so the whole thing would be 2 bromomethyl, okay. Wait, that's not good. Sorry about that. I don't need any numbers here. This should be 2-bromomethyl, and then it's 2-butenyl. You have to be careful with your parentheses in your parentheses. So this is one big group. It's not a bromo. You're probably saying, that's not a bromo, and you're right, it's not a bromo. It's chloro. Chloro. Where did that bromo come from? You'll see in the course I love bromine. I don't know why I do, but I just do. Okay, so chloromethyl. So this is a 2-chloromethyl. So in this position you have a chloromethyl, 2-butenyl, and this is referring to the position of the double bond. And then where is this? This is all at the 3 position. Okay, so that's kind of a complicated side chain. Now, we can put the whole name together, okay? And I'll do that in a minute. But I want to do the stereochemistry, and I want to show you a couple things we were talking about in my office today. And the first thing is all this switching around. You know, we did all those switch methods in class, and that's okay. And some people are using stereochemistry, women, and that's fine. Okay, but I just want to show you something. Remember, every time you switch 2 groups, you get the opposite thing. So if I were doing this this asymmetric carbon, this would be number 1. This would be number 4. Okay, and you can work this out. I'm not going through all the priorities right now. But this is going to be number 2 over here. And this is going to be number 4. And this is one of those cases, whoops, that's not right. This is going to be number 3. This isn't like a super hard case. Like you would just trace it, and ordinarily you'd go 1, 2, 3, it looks R, it's really S because it's backwards. But I was going to say to people, if you really get trouble with all the busyness of something like this, it's helpful to just write the numbers in. So just draw the shape, the general shape like this. This is just a little trick, little clue for people who are having trouble. And you would put 1, 4, 2, and 3 like that. And that's really helpful because then it's not really busy looking and you don't get distracted by all the rest of the structure, okay? And then you trace the circle, you'd say, oh, it looks R, but it's really S. And that's probably how I would do that one. That's probably as complicated as I would get. So this is an S center, okay? This one here is tricky because it has the, it's not so tricky. I wanted it to be trickier than this, but it has, let's see. No, it's not so tricky because number 4 is coming out. So this one isn't so tricky. I'll show you one like that in a second. But this one, this would be, let's get rid of all these numbers because we have numbers all over the place here. This would be number 1, okay? Okay, this would be number 4. So number 4 is actually coming out toward us again. And this would be number 2, simply because this carbon's hooked to an oxygen. And this carbon is not. Okay, I'm trying to be careful here. All right, so then you trace the circle. It looks R, but it's really S again. So I made an SS. I'm going to show you something to do when it's in plane, okay? And then this guy, right, what I wanted to point out is these double bonds, you would not assign Z or E to them because they're in a small ring. And in small rings, you really don't have ZE. This one, you would not assign ZE because it's a terminal group. But this one here, you can assign ZE to it, and this is going to be the higher priority group on this side, and this is the higher priority group, so I believe that's Z. Okay, so what kind of crazy name do we get out of this? Let's see if we can write it out. How much? Which time am I at?
11:30.
Okay, good. So, how would I write this name out? Okay, I'll try to do it up here. Can you see that?
Mm-hmm.
Okay, so, oh, I just erased my name. So what's going to come first in the name? Let's see. It will be the bromo. So it's going to be, this is 1, 2, 3. So it's going to be a 3 bromo. Let's put the stereochemistry in first. It's 2S. Okay. 3S. Okay, 2, 3S. And then it's 1, 2, 3. So it's 3 bromo. Okay, what comes next to my name? I erased everything. I think it's this thing. So all we've got is this and this and this. So that's pretty easy. So it's 3 dash 2 in parentheses chloromethyl. So I'm saying at the 2 position on the side chain, there's a chloromethyl, 2 butenyl. And again, this refers to the double bond. Okay? And then, oops, yeah, I'm okay. Then it's dash, I'm going to the next line here, 1, 3, cyclo, penta, dienyl, okay? And then the main name, which I remember, as I recall, was a known, it was, let's see, 1, 2, 3, 4, 5, 6, 7, 8. So it was a 8 nonene 2 all. That's the whole name. Now, what do I not have in here? I don't have the Z in here. So the Z, so this is a little tricky. You say, well, how do you put that Z in? This is a little bit outside the range of what we've done. But just so you realize, what you would have to do is you'd have to show it here. Excuse me. Right here, rather. So you would say 2E butenyl. Okay? Now, I'm not going to give you something like that, but if you understood that, you probably get a lot of what we've been doing. All right, now, and realize you're going to have to put the stereochemistries in the name. I'm not too picky. Sometimes they're in parentheses, sometimes they're not. Just put them in numerical order. That's fine with me. All right, so a couple other things. What I wanted to say, too, is when things are in plane, so if you have something that's in plane, like say your number 4 is in plane, like this. This is not a terrible thing to do. Like say you've got something like this, I don't know, something like that, and you're trying to just assign that stereo center. It actually has another stereo center, but you're trying to assign that stereo center. It's a little problematic because the number 4 priority group is going to be this group. So this is number 4. And you can check these, go through them step by step. This is going to be number 3, this is going to be number 2, and this is going to be number 1. And I'm doing atomic number first point of difference. So again, this little thing we did in my office I think is useful. You could just draw your numbers in a spatial manner, like draw them like this. There's always a better way to do it, a different way to do this. And like I say, a lot of times students give me ideas for how to do things. So I think that is a very simple way to deal with structures that are more complicated. And, the thing you can always do, right, is you could just get in the habit, when your number 4 is in the plane, you can redraw the number with the number 4 going back. And we want to avoid having too many switches. I think that's a little problematic. And then put your number 1 in the back. So if you switch your 4 with whatever's in the back, okay, which is what I did here, that puts the 4 in the back so that when you trace the circle, right, it's R, okay, but you did break bonds when you did this, so this is really S and this is really S. So I think that's a way to do it simpler and then get in a habit of always putting number 4 in the back position. The last thing I wanted to bring up is just about making decisions if you have 2 molecules. And I just want to say that there is a interactive flow chart that I'm going to send you tonight that you can look at that shows you how to make decisions about the relationships between 2 molecules. So if you have 2 molecules, A and B, the first question you always want to ask yourself is, do they have the same formula? And I kind of did this in class, but I have this interactive flow chart I'm going to send you. Do they have the same formula? Okay, now one of the quickest ways to find out if something has the same formula is to look at the unsaturation number. If they have different unsaturation numbers, they definitely have different formula. And if they're different, right, they're definitely not related. And I think it's very important to write no relationship, not to say they're different. Enantiomers are different molecules. They can be put in separate bottles, okay? If they're the same, okay, then you have to start trying to find out what their relationship is. So then you check for connectivity. And this is what people tend to forget to do. They tend to look at the really simple thing first. Connectivity means it either has the same iupac name, or if there are molecules that you don't know how to name, you could just sort of road map them along. And if you run into a group in a different position in the molecule, and you have to kind of check it in all directions, but if you run into groups like, say a methyl group's in the 4 position in one and in a 3 in the other, and you really don't know how to name it, and you check all directions, and that's what you determine, then they don't have the same connectivity. But if you can name it, you can just name them, and if they have different iupac names, then they don't have the same connectivity. If the answer is they have different connectivity, all right, then they're structural isomers. If they have the same connectivity, then you're in the land of stereoisomers. One thing you can check for right away with your stereoisomers are the double bonds. So if one has a cis double bond and the other is trans, like if that is the case, then they are definitely diastereomers. If the answer is yes. So I'm saying if your molecules, you have 2 molecules, they each have a double bond, and one has a cis double bond and the other has a trans double bond, regardless of anything else in the structure, if that's the case, they're diastereomers. And remember that they may or may not be geometric isomers, technically, but remember, geometric isomers are a subset of diastereomers, so you could just say they're diastereomers, okay? The next thing you'd want to do is look at asymmetric centers. So at this point, I'm not going to finish this because I'm going to send you this interactive thing to look at because it's got a lot of detail in it. But that's kind of how you go through the process, and that's a little trick you can use to establish stereochemical relationship very, very quickly. If you decide they either don't have double bonds or they the double bonds are both cis or they're both trans, then you'd want to look at asymmetric centers. And then you'd be saying, is one asymmetric center R and is one S? If one is R and one is S, then they're enantiomers. If they're both R, they're the same compound. And again, this exam, because we actually are a little bit behind. It's a little scary to me that we're behind already. But we'll get caught up. But you really, I forgot what I was going to say. Sorry about that. But you really are only going to have one center in anything that I give you. Even if I showed you a couple centers here, you'll only have one center. But we've got to quickly kind of rev up to having multiple centers. Okay, so good luck with your studying, and I'll see you on Monday.